So I'll just hit that. And so maybe we can start introducing ourselves and then we'll move on from there. So my name is Judy, and I am an interventional radiologist. I'm on call, that's why I have scrubs. Hopefully I don't get called in between now and then. And I do informatics, and I got into AI. What I like to do is study how models fail in real life and how they're translated into clinical care. I'm also very interested in issues around bias and explainability. But I find myself very, very self-nourished by mentorship, and so this is a great opportunity for me. I'm not going to be teaching, I'm just going to be facilitating, and we'll all learn from each other. And I hope we'll have a wonderful time and just form like a support group to get us to another level, okay? So don't give up. If you don't understand anything, ask. If else, just go back and rewatch the video. Like, the idea of this is to use a flipped classroom where you'll read on your own, but when we're together, we're trying to help each other work through problems, okay? Today there's no programming task, but you know, for the future, from the next week, there'll be a programming task. And so the other thing I'll do is I'll also create a channel on Slack so that we can always just have a place for us to ask each other and just talk through the week, so that you just don't only have 1 week to look at this, okay? Okay, Abigail, do you wanna go next? I'm just going alphabetically.
Okay, I'm Abigail. I'm a radiologist in IR. Used to work at Emory, but I got interested to do this AI stuff or internet stuff, but with Dr. Judy. I'm very, very new to all of this, so I'm learning from the basics. And I'm happy to be here, and I'm ready to learn and kind of want to explore this area and see how far I can get. And if, I don't know, just to learn something new, a new challenge. Okay. I guess someone else can go.
Is it me or is it IJ Journal? Depending on the... Hello? Hello? Oh. Hi. I was wondering, is it me or is it Tobiola? Who's going next? I think I can go. Can you guys hear me?
Yeah.
Okay. I thought I was talking to you.
Sorry, I was on a call. Chima?
Hi. So my name is Chima. I'm a current computer science student at Tech. Yes, and I'm actually really interested in the field. Relatively, I try to bridge my knowledge gap. I try to learn more, pretty much learning, and try to do more. And hopefully I can get better at doing that. Yeah.
Awesome. Elmira, do you want to go next?
I'm Elmira, and thanks, Judy, for adding me to this group. That's wonderful. Exactly what I was looking for. I am R4 radiology resident at the University of Illinois in Chicago, and I'm very interested in IR, in AI, not IR. And but again, so there's it's really hard to find a good mentor. At least in the institution that I work at, like who's also interested in like medical imaging AI. So I approached Judy, and like she invited me to this group, which I'm happy to start learning with you guys.
Awesome. Toby?
Okay, my name is Toby, and I had my first degree in computer science. I am interested in biomedical imaging and applications of deep learning in health, and I'm looking at solving the problem of maternal death, and that is because most of these deaths are caused by fear from the the pregnant woman, most of them they get informed that they might give birth using CS probably during the third trimester of their pregnancy. So that is one of the major causes of maternal death in my country. So I'm looking at how I can apply biomedical imaging and deep learning approaches and methods to solve this problem.
Awesome.
And I'm very grateful to be here. Thank you so much, Dr. Didi. It's a big privilege. Thank you.
Yeah. I think, Toby, you have a PhD admission to UIC, right?
Yeah, yes, I do.
And Elmira is at UIC, right?
Yeah, exactly. So are you are you a PhD candidate here, or did you are you a postdoc here?
A PhD candidate.
Yeah, he just couldn't start off because because Elmira will have moved on by the time you come, but you know, he just didn't start because of COVID and visa bans right now. But yeah, so he would be.
You're not currently in the US, right?
No,
No,
it's very late for him. Yeah. And Chima, you're from Nigeria originally, right? Yeah. So Toby is from Nigeria. Okay. Okay. Awesome. So can we go ahead? You guys are okay with that? Okay. Yeah. So one thing that this book is good for, so just to make sure we all know why we're all here. And I have so many slides, so many screens, it's not slides. But this is just going to be very, very interactive. And so I hope you got a chance to get the book, and I hope that you got a chance to read the book. And I have many things here. Okay, good. Can you see my screen, the book? Yeah, so we're going through hands-on machine learning. There is a very, very good course that I like, and now they actually have a book. Elmira knows about this. It's the Fast AI, and I think I also had Toby go through Fast AI. And the thing, so this Fast AI course, so they have this book, Practical Deep Learning for Coders. And so one of my mentees who I talk to a lot, so you don't even need to buy this book because you can download the PDF with the GitHub for free. So what will happen is that we'll sort of come in between these two books. Now this book, you can see it says it's an AI application without a PhD. So it starts you from chapter 1 and you're building things from the word go. But what happens is that you have so much knowledge sparsed out all over the place that what I want us to do is develop a solid, you know, understanding of the fundamentals and how to approach machine learning problems, right? So Toby and Chima, I expect you to be strong programmers in this. Elmira, I expect you to understand and be comfortable telling Toby and, you know, and Chima what to do, what you expect. And that's the same thing for Abby, okay? So you know, you don't need to be, and that's the thing, do not feel afraid and say, I'm not going to do this, this is too much programming. Really, the reason why I ended up choosing this book was because it starts from very, very basic fundamentals, which is why chapter 1 may seem to be very easy, okay? And so I'm going straight to, the good thing about this book, it has some questions, right? And I think we should just go down through the questions for discussion, right? And say, for example, how do you define machine learning? Chima and Toby may already know because this is their stuff, but Abby, what did you, and I'm not going to pick on people, what did you understand in terms of machine learning? And you don't have to replicate the same thing.
I mean, from reading, I kind of got is like trying to replicate or understand a system in the way it works, like, and also kind of like predicting the outcomes of how it's going to be using data sets.
Mm-hmm. Okay. Elmira, did you have a different understanding?
I just built my understanding based on the way that this book defined it. And it looks like if we can get an algorithm or a machine or whatever, get better in a task by feeding it with some data, and like we can just measure its performance somehow. And if it's getting better, so that this is like a machine learning process. And this is what I think.
Okay. Chimo or Toby, what is your understanding of machine learning?
For me,
Yeah,
sorry. For me, it's pretty much also very similar in terms of if the algorithm or if the agent can improve based on some task E and learn from its learned experience, then that's how I defined it in terms of as long as it's improving. Yeah.
So and Toby?
Okay, for me, I think machine learning is teaching a computer how to learn. So not just solving a problem, but knowing how to learn and iterate over time on other kinds of problem.
Exactly, right? So it's teaching a machine how to learn, right? And why is this important? It's important because if you think about a baby and they're learning how to speak, right? So how do you teach a machine how to speak? How do you teach a machine to read and understand comprehension, right? And people will say, how do you teach a machine to smell? So yesterday, Elon Musk released a brain interface like chip that's being mounted on a pig, you know? And can you start to control signals, right? So you're simply saying that you're treating the machine as its own being that learns to gain these skills, right? And so if you look at sort of this example here, and I like the example of spam mail, right? Everyone has email. We, unfortunately, Chiba and Toby, we've received those emails from Nigerian princesses and transfer money and do all those things, right? And we know, and people fall for this scam, but we know that this is a scam, but we get a lot of spam mail, right? But today, I cannot tell you what sort of spam mail, what sort of mail, if you think about how many emails are sent in a second or a minute, there's so many for me to, as a human being, to come and say, oh, I think that if people use, so the example they say here is that if maybe you say, for you, credit card free, amazing, Nigerian princess, that those things should make you think it's spam, right? So you'd have to know all these rules. Traditionally, when we say about programming, you'd have to know the problem. So here you'd say you want to write a system that prevents spam, then you'd have to write the rules. So you'd have to know all these rules and you have to evaluate it. And if it's good, you deploy the system. If it's bad, you analyze the errors and you come back and repeat, okay? But if you think of machine learning, you really never know or write the rules. All you know is your problem and the data that you have. So in this spam example, you may have 10,000 emails, and we're going to go to the types of machine learning, but you can have them, Abby may say, this email is marked as spam, right? We do that. I mean, I hope some of us do that, right? And so if you start to mark as spam and you have this data, then you can study the problem, feed the data. The data can be labeled or not labeled, and the machine is going to teach itself by iterating and looking through a mathematical function to understand the patterns in the data. And then you are still going to evaluate it. If it has errors, you repeat the problem, or else you learn. Does that make sense? So when a machine tries to understand language, then that becomes natural language processing. When a machine tries to understand imaging, is this a cat or a dog? Is this pneumonia or non-pneumonia? Then that becomes computer vision, okay? And now that's why this book, I like it because it starts to talk about what are some of the examples, right? You can imagine analyzing images of products in a production line to automatically classify them. So I know that some people have cups, right? If you're in a factory that's producing cups and you don't want some with defects or clothes, right? You could teach a machine like what's a defective cup and what's a good cup. And it automatically starts to just take pictures and pick out the bad cup, okay? You can see that we know we're in imaging, we have this area called semantic segmentation, which you're drawing, the area of the tumor, and you're going to say this is the tumor. So you're identifying tumors either on brain scans or liver scans or lung CT scans. You can classify news, and this is where I say when you're dealing with text, you're thinking about natural language processing, you know. And don't worry about all these things. I just want you to know that they exist, because by the end of this book, you'll have understood what they mean, okay? I want you to be able to sit through a lab meeting and understand, oh, this is what's happening. And for Tima, when I give you a task, I want you to say, I'm going to use this approach because, you know, like the wisdom task, okay? And so you can flag offensive comments, right? So you're classifying text. So Abby here, we could say that we call our patients before our IR procedures every time. You could listen to the voices, make them into text, like speech to text, and then say, oh, 5 people are calling about medications, 5 people are calling about complications. So you're finding groups into them. You can summarize long documents. So this is used in law, legal stuff, because you can imagine all those big documents, but it's going to pick up all our key themes. And for medicine, sometimes this is used to generate patient-friendly words for, you know, text reports. And so Elmira, you'll see this where they summarize the, you know, like the radiology report in a more patient-friendly language. You can create a chatbot or a personal assistant. We've seen some of these, right? Even if Siri and Alexa, those are voice initiated, but that's how they're powered, by creating a chatbot. Predictions are big things. I know that if you've sat through our lab meetings, you know that we're predicting who's going to be readmitted with COVID, right? Who's going to need an ICU bed? Who's going to go home? You know, who's going, you know, people have looked at lung cancer scans and said, what in terms of lung cancer, what type of lesions is going to be a cancer in 1 year, or breast cancer, what's going to transform? So this type of prediction, making your app react to voice commands. I think we're using a lot of speech recognition. As radiologists, we know we dictate our reports, detecting credit card fraud, and sometimes this is clustering. And clustering is interesting because in the past you knew that when men go to the store in the US, they go and pick beer and diapers. So most of those things now tend to be put together in a store. So those are some of the potential uses of machine learning. You can use visualization. Dimensionality is that sometimes you have so many features, and I think you've heard about this on some of our data sets, that we have hundreds of features. So how do we reduce them to figure out what's the most important? And we'll learn strategies for those. And you can do recommendation systems. This is mainly for Amazon, right? It's going to tell you people who bought this, like this other thing. And obviously gaming and robotic is a big thing. So I'm just curious, what things did you, when you read these examples of applications, what things did you think about? Like, you use AI, not AI, machine learning. AI is a form of machine learning, but what did you think that maybe in your life you use for machine learning and maybe we don't think about it? Or what are you excited? What was surprising? Or what are you building right now that requires machine learning? Or what do you want to build that requires machine learning?
Pretty much for me personally, I like the self-assistant systems. I think Siri is not at her best potential. I probably can be rude.
Okay.
I think personally that's probably where I like that. I like natural language. I like the idea of being able to communicate, because I think that's sort of what gives people the illusion of life and makes it feel more natural.
Okay. Elmira, I kind of know what you want to build, but the group doesn't know.
So again, as I discussed, like as I told you before, at the moment I don't have any question to answer. But if I could use which lots of people are already using, like machine learning, to do some signal processing of the MRI signals that we receive. And by the way, guys, I'm very interested in neuroradiology, neuroimaging, and particularly the functional MRIs, which we basically see how the brain works and like get the MRI signals from that. And I want to learn how to use machine learning in processing those information that we receive. And if you can just find, so it's like very time consuming, this task, if you just do it yourself. A lot of people, until very recently, lots of people just do it using like statistical softwares, and still are doing that. But also like some other like new with development of different like machine learning and like deep learning algorithms, they're able to feed all these like signal data to an algorithm and like figure out what's going on with the brain networks, for example. What is so what would define so they can classify like a brain network of a person as normal versus as abnormal, or like have a certain disease. So that's what I'm excited about, and I'm trying to like go to that direction.
Awesome.
But it's not something that I will build. So it's already built there. I'm just trying to like learn how to do that.
Awesome. Abby?
For me, the one thing that kind of I would want to see more, it's like when in IR, when the doctors place the orders and stuff, kind of like create a system where you know the symptoms and you know what's going to happen and be able to choose the correct orders instead of me going back inside and changing it to the correct order. That reduces like figuring out what's this, what's that. Is this what we're doing? I feel like that would help a little bit for our workflow as a technologist.
Awesome. Toby?
For me, I'm majorly interested in imaging analysis, segmentation, and also let me say the use of generative adversarial network, such that you can change a picture, or you can, when someone talks, you can use the same voice for another person. So the future looks so exciting, even as in the application of GANs. So that's what I'm interested in, but majorly medical and biomedical imaging analysis.
So Toby introduced a new term, right? GANs, generative adversarial networks, right? So when you teach a machine, when it learns a pattern, it can generate more imaging, right? So hopefully Toby will be an expert by the time we're done and will be teaching us about GANs, you know? So I don't know if you've seen these videos where they show Obama speaking, but it really isn't. They use his speeches from previous time. So it's very dangerous, right? Technology, because they use his speeches from previous time and they now start to make him say, you can have him say vulgar words, right? Or you can have him speak for like supportive Trump, or, you know, I don't care about the political affiliation of everyone, but what I'm saying is that you can imagine in an election, right? You can, it can really, if you can generate fake stories and fake news, then it can be very, very dangerous, you know? So the GANs is a big thing. And you can imagine with medical imaging, if you do not have enough data, then the way you do is you have someone generate. So if you don't have enough signal from your fMRI mirror, you just generate it to someone else, okay? So I think that brings us to maybe question 3 about this, what is a labeled training set? So there was something in the algorithm, and this is super important. When you decide that you want to train your workflow algorithm, Abby, what's a training set, what's a validation set, and what's a test set?
Ooh, I don't know the answer to that question.
Phone a friend.
Yeah, someone help me. Let me look at the book.
I can help.
Mm-hmm.
Yes, please help.
So the way I understand it, this is the way I understood it. You traditionally, you split your data sets. So the data set is the set of data in which you want to train, in which you want the program to learn from. So like in the spam email example, the data set is the whole list of emails, right? And in that whole list of emails, so there will be 2, either it's spam or not spam. And when you indicate that, okay, when in the data set, you're saying there's spam and no spam, that's when it becomes labeled, because you've labeled each email as a spam email or non-spam email. The way you'll say it is sort of like, okay, if it's a spam, let's say give it a usually binary classification, like 1 or 2, 0 or 1. So if, let's say, the email from Nigerian Prince is a spam, you label that as a 1 in the end. And then email from Judy, you label as a 0, meaning that's not a spam. Judy is valid. So you would have a bunch of data like that. And then, so you split it and then you divide the data set into, let's say, 2, your training data and then your testing data. And then, so the training data is actually what you feed your algorithm. That's where it learns the patterns. So from the training data, it's gonna say, oh, Judy doesn't mention Prince, spam emails don't mention Prince, they don't mention money, they don't mention $10,000 you win, they don't mention that. So that's pretty much where it'll pick up all the features from that. That's the training data. And then, so you now want to check and see, okay, is this valid? Will this work on new emails? Then that's where you test it on the testing data as well. And then the last one is the validation data. So sometimes you split your testing data into 2 as well. And you have your original testing data, and then you have your validation testing data. The validation is to make sure your training data, your testing data hasn't been generalized, which is a new term too. So generalization just means if it's gotten really good and it's, let's say it learns a pattern and the pattern only works for the training data or the testing data. You don't want it to be that. You want it to be able to learn on any other email you give it, such that. That's pretty much why you do the testing and the validation. Yeah.
Awesome. So just exactly like Chima said, right? Remember, we are not providing rules when you use machine learning, right? We're telling the computer, learn. So let me give you a different example. Let's say Abby will know this, but there's a mountain called Mount Kilimanjaro in Eastern Africa, where people go there to climb there, right? The Mount Everest of maybe Africa. And so if you go, so you could say, okay, I'm going to plan my trip and plan, I'm going to use this route and do everything, right? You can think about as traditional machine learning. You already have your rules, you know where you'll be doing, where you'll be sleeping and doing everything else, right? But what if everyone who went recorded their route? So you have where you start from and where you end. So you have your data set, right? And now you're going to say, machine, tell me the best route to take from all these 1,000 routes that have been taken by explorers before me. So if I tell them that, if I give the machine all the 1,000, right? How will I know it's learned the correct thing? So I have to keep some data to myself called the test data set, okay? That's for testing, where I know the truth, but the machine doesn't know the truth. It's never seen this data. So it's going to, then when I see, oh, you really thought this was the best route, but people have died on this route, then I know the algorithm doesn't work well. So the test data set is just the same way as testing, where it allows us to evaluate the performance of the machine. Now, as it learns, what we do is that, so you can imagine if I'm at the top of the hill and I'm coming down, so the machine, first of all, takes me through a place with lions, and then takes me on a slippery road where someone has fallen. I don't want that route. I have a chance to be eaten by a lion and I have a chance to fall down and break my neck. So I tell machine, bad machine, you went, so you penalize it and you punish it. And that algorithm that tracks what you're punishing the machine in sort of like neural networks is going to be called the gradient descent. Okay, so you're trying to say, and I think you saw something in this right up that talked about the learning rate, the steps that you're taking as you come down the mountain. So if you're like jumping very big steps, then you miss on learning if you have very large steps. But if you're taking too slow, you're never gonna get to the bottom of the mountain. And so we have to optimize this parameter called learning rate to get better to understand what what's the optimum number of steps and the route that we should be taking to get to the bottom of the hill. And so if you think of, I've talked about the training data is where you give this data to the machine because you're not giving it rules, and then the test data. Now the validation data is another holdout set that the machine is going to keep getting better on, you know, and then finally you're going to show it to the test data. So that's very well explained here. You'll see something like a holdout set. And I just wanted to review sort of these challenges of machine learning because we're talking of data. So if you do not have enough training data, then a machine cannot learn the pattern that you want. And then if you have non-representative data, so this is a big issue right now with facial recognition, right? So if all your data sets are all of white people, when they see people like us, then they're not able to identify them because they could not learn those patterns. And then if you sort of look at poor quality data, right? So this is an area that if you want to be in this space, this is where we'll spend a lot of time on making the data clean. And then if you have irrelevant features, Chima talked about features, right? So you'll pick up what are some of those things. Maybe it's the sun, you know, the time of the day. If it's too dark, the route becomes dangerous. So maybe, you know, the weather, the time of the day, the month of the year based on the season are important things when I'm climbing down or climbing up this mountain. And so those things are, you're selecting what's most important for features. So this is something you'll hear a lot on our lab meeting, like, oh, what features did you see? How the features performing? And because you can have 1,000,001 features, we have to reduce them or collapse them into a form that allows us to understand them. And then sometimes we have to gather more data to tell it. So this example of overfitting and underfitting, I think someone is trying to join our meeting. Give me 1 second, guys. You know, so if you think of, so Pri just joined us, he's going to introduce himself, but if you think of overfitting, it's where, and I'll show you another example, is where you learn this line, if you think this is the best fit, is matched up to every single point. So this line is not useful. If you say, what's the happiness index for Kenya? It's not going to perform very well. And so what you do is that sometimes you have to make sure that you have to constrain the model and reduce the risk of overfitting. And this is what they call as regularization. And so if you look at these 3 models, you can see that this model is trained on all data. And then this dotted model here is trained on partial data. And this is one that's regularized. And you see it fits in between the two, which is a better performing model. Okay, we'll get to learn how to do curves a lot. And so underfitting means your model is too simple to learn the underlying pattern, you know? And so if you have this, then you have to either, you know, reduce the constraints, feed better features, or choose a more powerful model. So I just want you to read through sort of these data problems, and we will see them because this is how our models will fail. Okay, Pri, do you want to introduce yourself? We already met each other.
Yeah, sure. Shall I turn on my video?
Yes.
Can you see me?
Yeah, we can.
Yes.
Yeah. Hi guys, myself Priyansu, and I'm from India. I work at Mentor Graphics India Private Limited, and I'm working with Judy since last 2 years. So I mean, I collaborate with her, but I may be new to you guys. I know Toby as well, but I don't know others. So it would be good if you also can introduce yourself. My background is in the machine learning, as I work on the autonomous driving project in my office, and my research project also involves computer vision stuff. Like mostly I've done on the chest images and all the PNG images, most of them are only chest X-rays images. And recently I worked on the time series data in the PGLP challenge. So yeah, I mean, most of my stuffs are concerned with machine learning only. So that's it. That's it from my side.
Okay, guys, let's take a moment to let yourselves speak.
Sorry.
I'm just telling so you know Toby, but you don't know Chima, Amira, and Abby.
Yeah, I don't know them.
Okay. I think
Yeah, I was saying I don't know them.
You guys wanna give a one line, because we're gonna be hanging out with each other the whole for quite a number of weeks.
hi Pri. My name is Chima. I'm a CS student at Georgia Tech. I'm really interested in ML. I first made contact with Judy, I think when they were looking for a research assistant. I remember when. What was it?
Amira?
Hi, I'm Amira. I'm a radiology resident, and I'm at Chicago, University of Illinois. And I'm interested in neuroimaging and not particularly computer vision, but just some sort of signal processing. And I'm trying to learn how to do that.
Abby?
Hey, Pri. I'm Abby. I've worked with Judy. I'm a radiology technologist in IR. So I'm just trying to learn something new and trying to see.
Well,
I
this
don't
I
know. Exactly.
Yeah.
But I am not at all aware of these medical terms. So it's Judy only that tells me, okay, we have this thing, we have that thing.
Okay.
So we went through what is machine learning, types of problems, and we just finished in terms of training, validation, and test set. Does that make sense to you guys? Right, so all your projects will have that. And usually you'll find that there's an 80, 10, 10, and many times types of splits for the uh, machine learning. So I wanted to come to this area where, supervised task and supervised task, because this is going to be these types of machine learning, okay? Does anyone want to take us through what they understood about this?
Maybe Toby or someone else.
Okay, for supervised task, there is always a label. But for unsupervised task, there is no label, so you don't know the outputs. You just have the data. And then examples of supervised task, we have classification problem, which is used for non-numerical data, and we have regression problem, which is used for numerical data. While for what is the other one?
Unsupervised.
For unsupervised learning, we have clustering, and we have principal component analysis. That's a type of dimensionality reduction, where we group the data set into different clusters.
So good. So I'm not going to, because all these are chapters coming up. So don't be too overwhelmed if you don't remember what one is. I've also actually never used some of them, so we'll all be learning them together. So what is important is to understand these types of supervised learning versus unsupervised learning, right? Supervised, you already know the question and the answer. You have the email and you know whether it's spam or not spam, okay? And then unsupervised learning is where you do not know anything. You're just saying, I'm going to put in all my reason for exams and then show me what are some of the clusters that come up, right? And then there was one more example here where they talk about semi-supervised learning. And I like the example that they gave, which is photos or Apple photos, right? It's going to say, these are pictures of Judy, 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 but it doesn't know this is Judy. It just knows that this is the same person. It groups them together into a cluster. So that's a form of semi-supervised learning because you didn't tell them that this is Judy. And all you have to do is say, oh, these are the people in these pictures. This is Pri, this is Toby, this is Judy. And so so you're mixing in a component of clustering, but at the same time saying that you have, then you give it closer, like the final label. Okay. So that, so this type of learning, reinforcement learning is mainly used for robots. Okay. And what it this is the type of, and this is actually, Almira, where you have to learn reinforcement learning when you come to think of time series data or signal data, right? And what you have to think about is to say, if you have to teach a game, as a computer to play a game, you want to say these are the possible rules, these are the parameters, because else if it has to learn everything in the world, it won't understand it. So it observes, the agent observes, and then if it selects an action, and then if it's the wrong action, it gets penalized, and then it updates the policy, and it keeps iterating till it finds the right thing. And so maybe the most notable example for this is the Go game, which you should look up. The DeepMind AlphaGo, which it beat the Key G, who's at the game of Go. And what it did was analyze the winning policy by analyzing millions of games. So it looks at millions of moves, and then playing many games against itself, because it knows what's a winning game or not a winning game. And so when turned off learning, it had learned, gained all these things, and then was able to beat the sort of the world's champion. And so this was a big move for reinforcement learning. So reinforcement learning is used a lot in language, as we'll see, something like LSTM models and GRUs. And it's also used a lot in robots, because you're giving reward for everything. So if the robot walks on the right path, then you give it a reward. Any other thoughts about these types of classifications?
In terms of the degree of complexity of these different methods, so to me it looks like because the reinforcement algorithm that needs to like generate the whole strategy, that should be like, is that like one of those more complex algorithms, or should we even do compare their level of complexity at all?
I don't know that I understand your question per se. The models and so if you look about these types of machine learning, this can be very simple examples, but when you start to go to the artificial neural networks, those are very complex. Right. So the traditional machine learning tend to be simpler and with fewer parameters. But if you use sort of any form of like reinforcement neural networks, those tend to be very, very complex and with lots of parameters, which is why they become a black box, because we don't know why they're working or why they came to a decision. Okay. So number 6, what type of machine learning would you use to allow a robot to walk in various unknown terrains, right? It's reinforcement.
Maybe just to add one more comment. Like you told about the reinforcement learning, we can similarly use the the neural networks as well as the LSTMs. LSTMs are also a type of neural network only for the supervised and semi-supervised learning as well. So we can train them using labeled data.
And
I just told to just avoid the confusion regarding the reinforcement and regarding the supervised and unsupervised.
Okay. So so we're just gonna go quickly, because we just need to know what are you going to start with here. So what type of algorithm would you use to segment your customer into multiple groups? No, takers.
I said I whispered clustering.
What?
I was saying clustering.
Yeah, right.
That's what I was thinking too.
Yeah, because if you want to figure out what groups there are and you don't know the groups, then you'd use an unsupervised approach of clustering, right? How would you frame the problem of spam detection as a supervised learning problem or an unsupervised learning problem? This is a philosophical question, I believe. Right?
But this is a good question. Let's see the response.
Wait, are you guys having like a chat or somewhere else?
No, we just have the screenshot that I'm sharing.
Oh, okay. So I thought like you guys are not verbalizing what you think and just typing it somewhere.
Oh, do you prefer that? That's okay.
No. I was just asking to know because.
Toby, what do you think?
I think it's a supervised learning approach because we have the labels spam and no spam.
Okay.
Me too. It's just a supervised task.
Okay. But I have some answers to the previous questions, you know. So machine learning is about building systems that can learn from data, and learning means getting better at some task given some performance measure. And it's great for complex problems where we have no algorithmic solution to replace hand rules and to build systems that are adapt to fluctuating environments and to help people learn. So label is a training set that contains the desired solution. And the two most common supervised tasks are regression and classification. I think we went through this through Toby. And reinforcement learning is what you'd use, but you can use, and I think this is what Pri was alluding to, you can also be able to express the problem as a supervised or unsupervised task, but that would be an unnatural use. So the answer for grouping is you use a clustering algorithm to segment your customers into similar customers. But if you already know the groups of your customers, then you can classify. You can use a classification which would be supervised, okay? So the spam detection one, I think we went through, it looked like supervised, but I think it's, you know, is a typical supervised learning algorithm because you have to label many emails and you have to label them as spam or not spam, okay? So there's this concept of online learning system and out of core learning systems. What was your understanding of those two things? So all this number 9, 10, 11, actually up to 12 was really like understanding how, you know, these are the new, so we said there are many ways we can classify machine learning algorithms. So there's whether they're trained with human supervision, whether or not they can learn incrementally on the fly, or whether they work by comparing new data points to known ones or building a predictive model. So could someone just remind us what online learning is?
So I think with online learning, you sort of feed the algorithms your data set in batches. You don't give it all the data set at once, and then it trains on those, and then pretty much it watches if the accuracy, it watches the trend of the accuracy, and you can correct for that as well. But I think with online learning specifically, you don't give it the full training set, you give it small batches of training sets to train on and learn from.
Okay. But this can be confusing with the example you gave, right? Because there's batch learning and online learning.
So the way I understand it is that, so when you do, when they define online learning, so that your algorithm learn not only like what to look for, but also learn how to adapt to new incoming data. So we are basically asking it to learn two things. One, the actual thing, and then the second one, the adaptation. And we do that by like feeding the data, like little by little or whatever approach we choose. And then so that it will be able to next time when it sees new data to like understand that. On the other hand, the batch data is that the algorithm is built in such a way that it will only be able to understand the whole data at once. So it will analyze the whole data at once, and then later on, if you want to, and then you will go ahead and use it. And later on, if you want to, if there's like some new data added, you can't like feed that just new data as like a little batch. So you have to like add that, like let's say we have like, we trained our model on like 1,000 like data points, and then you have like a new 100 data. You can't just feed that 100 data. You should be using 1,000 plus 100 data items and just do it, like train your model one more time, and then that's going to be like the new version of your model. So that's like the difference between the online and the batch form to me.
Amazing. That's like amazing. That's a great explanation, right? So batch learning, you're saying I'm going to, so Pri, do you think we usually use batch learning or online learning for most of our projects in the lab?
We use online learning.
No, I think we use
Intermediate.
batch learning.
We use the process of dividing the data in batch, but it's an online learning.
I disagree
Like,
actually. Toby, what do you think? Do you think we do most of our projects as batch learning or online learning?
I think batch, and that's because what I understand from online learning is if you introduce new data, you have to just train the new data that you introduced and not start from the beginning. But
Exactly.
what we've been doing in the lab, if you have new data, we have to train again from the beginning. So that's why I think it's batch learning that we've been using in the lab.
Absolutely, which is exactly what Elmira said, right? So batch learning, you're taking everything at a cross section. You true are using batches, but you're bringing this in. Like if you want to know a new type of spam, you need to like train from scratch. Now there's something called transfer learning, so don't let that confuse you right now. But if you look at the batch learning, you're training everything from scratch. But if online learning, you're training, but you're splitting this data and bringing it in sequentially, And so if you have like a new, for example, stock prices prediction, right? I don't know what the stock prices will be at 2 p.m. So if you're sort of putting that price and you want to collect, oh, these are the new stock prices at 2 p.m. and you want to bring them on, if you think of the way we train the algorithms in the lab, Pre would have to start from scratch. And so the work that Anant is doing with the one-shot learning, I think is an example of online learning, where you're just bringing in this new data, you relabel them, then you come in and run on top of it. But the explanation that Elmira gave is really I think the best fitting explanation. Okay. So online system can learn incrementally as opposed to batch learning system, which is why it's capable of adapting to both changing and autonomous data, and also on training for big, large data sets. So what's out of core learning? I think this came in the online learning here. And it just said, if you're training these big data sets that cannot fit in one machine's main memory, then this is called out of core. And the algorithm loads part of the data, runs a training step, and then repeats the process until it's run through all the data. So you have lots of data, you chop them, and you're just loading it on the computer. If you're programming, then memory always runs out. So I don't know if that's super important to know. So what about instance learning? Or rather, I am giving the answer for this. What type of learning relies on similarity measures? So there was something instance-based versus model-based learning.
The way I understand it is that so process learning, we are not defining the energy for the machine and just say that we're just having them having our algorithm to figure out like we're just feeding some data, and next time and it's like trying to like figure out some patterns in that data, and next time when the machine sees a new one, we'll try to like see if the pattern that or features that he has selected already has some sort of similarity with the new data that we are exposing it to. And then obviously we have to like define what what degree of similarity is to our machine. And if it passed that certain level of threshold of similarity, it will just say that, yeah, probably this is like A or B if you're like trying to classify it. But on the other hand, that so this is the instance space. But the other one is that we actually have like give our model. Well, I shouldn't be using like model, or we're trying to like tell our system, like, or whatever algorithm that we're using, use this model, use this approach. Every time you see something, use this approach. And I honestly don't know how we come up with those approaches. Probably we use like probably to come up with those good approaches, like we call them models. I'm guessing that probably at first people have done hundreds of thousands of instance based analysis, and then based on those they've created these models that now we can use as in model based approaches. This is how I feel.
Yeah. So Toby, of all the code we write in the lab, do you think it's mainly instance based or model based?
I think model-based learning.
Yes, right? So we say, I'm going to train an AI that's going to detect COVID, right? I give it all the data, it predicts, makes the prediction. But I'm not using this similarity. So the measure of similarity is what makes it an instance-based learning, right? You show it many examples, and then it's like, oh, well, I know this is this. And so that's the main difference. So an instance learning system learns the data by heart. Then when given a new instance, it uses a similarity measure to find the most similar learned instances and use them to make predictions. And so this is probably a question for Pri. What is the difference between a model parameter and a learning algorithm themes parameter?
Oh, yeah.
So please repeat model parameter and learning.
Mm-hmm. This question 12. And you can phone a friend to help you.
Okay, let me try. I mean, I may be wrong. Model parameter is basically the number of neurons you say, and hyperparameter may be the learning rate and the batch size you are choosing.
Toby?
Okay, so I think hyperparameter, like Priyanshu said, I know an example is the learning rate and probably the batch size for hyperparameter. But now for the model parameter, I honestly don't know.
Mm-hmm. Yeah. Chima, did you have something different?
I thought that was actually good because I never actually put the distinction together in my head. I think I always clocked all of them on the hyperparameters. But if I'm to take a stab at it, I'll probably say, let's say with like your linear regression, maybe the model parameters are what would be the model parameters? The model parameters would probably be, what I'm thinking are the weights and the bias. And then the hyperparameters are the other stuff like the learning rate that you would give that.
Yeah. So the model, has, Elmira, do you have anything to add to this?
I mean, so I think the book described it very well. And so exactly the same. If we want to use that, like fitting a line function in our data. And so basically our model is trying to figure out what's going on in that data. And the way it does it is by a mathematical function. So the simplest mathematical function that we all know is a line. And that is, it has some parameters in itself. It has a slope of a line. It has like how far it has to be. It can be like very simple as like y-axis is a certain number, or it can be just as complex as all those with like square function of something, and like it can be simple or it can be complex. If we are defining how simple or complex our function has to be, if we're defining that, that is a hyperparameter, like because we are regularizing our machine to choose those. But if we are trying to set our weights, or set our by weights, I mean like the slope of the curve. So if we want to say, well, actually, this is not what we say to the machine. The machine will choose it itself, like the slope of the curve that best fit our data, or how far it has to be away from the zero line. And so these are like the model parameters, and the hyperparameter is just what we want the machine to choose as the degree of complexity of this mathematical function.
Right, so the hyperparameters make sense to all of us because we're always tuning them in AI, in neural networks, right? We're always changing the learning rate. Remember the example I was telling you about the mountain, right? We're changing the learning rate, but you're right, the inherent characteristics that the model says that this will be the slope, this is how much I'm going to change the slope, those are model parameters, okay? So, so a model has one or more model parameters that determine that it will predict a given instance, for example, the slope of a linear model. But a learning algorithm will try and find optimal values for these parameters so that the model generalizes well to new instances, and these now are the hyperparameters. Because they're not of the model itself, it's just the learning process. It's trying to say, how do I work well when I come to see new data, right? How do I prevent underfitting and overfitting, okay? Okay, so, and then, so if we go to 13, these model-based parameters, what's the common strategy they use to succeed, and how do they make predictions? Any volunteers? Don't worry, guys. Oh, it's already 1, so we should start wrapping up. We should be sticking to 1 hour. Oh, that's...
They reduce the cost.
So, I mean, the model-based algorithms, which is what we talked about, right? They search for an optimum value of the model parameters such that the model will generalize to new instances, right? And usually we'll do this by minimizing a cost function. And the cost function, sometimes also known as the loss function, measures how bad the system is at making errors or making predictions, right? And then it penalizes the model. So this loss function is going to be a very, very big word that we use moving forward, right? This is how because remember the machine is learning on itself. We've given the data, we've decided this is training, test, validation data set, and the feedback loop, that learning algorithm usually is like the gradient descent, but the way we're telling it, you're learning bad model is this cost function, which is the parameters, sort of like the penalty and that we use. So they're always trying to evaluate the loss function, which just shows us the error of the model, okay? So we went through the data problems that cause challenges in machine learning. And then I just want to hear a name because we went through this a little bit. If your model performs great on the training data, but generalizes poorly to new instances, what's the name for that? Yeah, I see Elmira saying, not saying loudly, but overfitting, right?
Oh, so do you not hear me well, enough? Should I speak up? I just don't know. Oh, okay, so.
Yeah, just flip red there, but it's overfitting, right? So you're working very well on your own data set, but not other things. So what are solutions for overfitting?
So we increase our training data.
Can increase the training data?
Change the model that you're using to train.
Sorry, what?
Using dropout and regularization.
Yes, so you change the regularization, you simplify the model. and you reduce noise in the training data, right? So that you remember that polynomial curve that was mapping every, so this is a good model. You know, you're not drawing a line across all states, but this is the example, this one, where you're drawing across every curve. This is an overfitting model, okay? And then we talked about the test set and validation test. And so there's this thing, train dev set. Almost there, guys, almost there. What's the train dev set? You can find it like
Is that something like really important? Like, is it looks like it's like a training so they just keep a little bit of training data away. Like, I just don't understand its difference from the actual validation. No, actually, I know that the difference between validation, but I don't know its function compared to the test set.
okay. So, Tima, Abby, do you understand what the train dev set is?
I remember hearing it in this thing.
So here is a good thing. It came in the data mismatch, right? So in some cases, it's easy to get a large amount of data, but this data probably won't be representative of the data that will be used in production. So white pictures for facial recognition, but you use it for policing for Black neighborhoods, right? So for example, suppose you create a mobile app to take pictures of flowers and automatically determine their species. So you can download millions of pictures of flowers on the web, but they won't be perfectly representative of the pictures that will be taken using the app on the mobile device. So if you only have 10,000 representative pictures, you know, in this case, the most important rule to remember is that the validation test and the test set must be representative. So if you're doing a facial recognition algorithm, your validation test must have some black faces. If in the real world, we're going to deploy this for policing Black neighborhoods. And so, you know, and so you should, so you can shuffle this. And I think if you've been listening to the lab meetings, you'll hear some words like class imbalance, right? Some tests, some classes are not represented in the data set. And so if this is the case, if you train your model on the web pictures, if you observe that the performance on the validation test is disappointing, you will not know whether this is because your model has overfit the training set or whether it's due to mismatch between the web pictures and the mobile app pictures. So one solution is to hold out some of the training pictures in yet another set that Andrew Ng calls the train dev set. So once you train the model on the training set, not on the train dev set, you can evaluate it on the train dev set. If it performs well, then the model is not overfitting the training set. If it performs poorly, the problem must be from the data mismatch. It's almost like splitting the training set into another subset. And I think most, maybe, I don't know if this is a good, but most people, what they do is cross-validation, right? They create these sets, subsets of the training data so that the model is tested across multiple data sets. Any other people want to attempt explaining this? This was also the first time I'd heard about the train depth.
Because if that's it, by the way, I think one of the microphones is just.
Could you mute your microphone, I think?
Mm-hmm. Oh, okay. So to me, it's confusing because if dev set is a solution for data mismatch, meaning that we think that our training data is not representative of the actual world data. So how keeping a little part of our training data away will just help us, unless it is just there to like help us figure out that is that like a data mismatch or mispresentation problem that we have. Maybe that's just something that we keep apart so not to like go and like figure out, like, for example, if we have like 1,000 data points to train with, so we shouldn't be like comparing every single new instances to that 1,000. We can just compare it to like 10 of them maybe, and then to see if.
Yeah, so when you have a model that's performing poorly, right? So you're asking yourself, am I overfitting, right? Have I learned the data too well? Or is it because the performance where I'm testing it is that data was not representative? You didn't have equal distribution of classes in the training, validation, and test set, okay? So to help you figure out which one is which, this technique, I've never heard of it before, where you create a train dev set, which just allows you, it's just a subset of your training set. So you're not moving your validation and you're not moving your test set. This is just like a subset of the training set. And you're saying, okay, I'm going to test the model on this. And if you see good performance, then it means, oh, you're not overfitting on this. It's probably a data mismatch and you should go and investigate.
Awesome. Yeah, that makes sense.
Yeah, Pri, do you ever use this? I know you probably are building more models more than most of us.
Not necessarily, because most of the steps are checked in while you're doing the data pre-processing. Then only you decide what is the distribution of your data. So suppose if you are doing on some random data and not random, but in the sense that you don't know what will be the future, then it's better to have a trained depth set. But if you know that the future is going to have this type of images only, then I guess train val split is enough. Considering the practical applications.
Okay. So I think I just want to hear what people's reactions to this chapter was. I believe that we went through everything. This no free lunch theorem just says that there's no way to figure out what's the perfect model. You just have to evaluate all of them, And then I wanted to go through a little bit of this code here, which was used to figure out like happiness, something like that, because it's good to try and run this code. And we'll walk through a lot of that. So this is importing in Python. You load your data, right? So we load 2 data sets, GDP, and I don't remember BLI, what it was, some happiness thing. And then you prepare your data into what you want, you visualize your data, and you select a linear model, which is the most simple model, because you imported this sci-kit plan here, sci-kit plan linear model. All you do is you run a linear regression. And remember, because you already know that this is a supervised form of learning, and then you fit the model, this just gets the best line, and then you make a prediction for Cypress. So I would encourage people to try this code. The next chapter is a lot about coding, and you should not be intimidated about this, really. I think it's a step-by-step. You can decide whether please do not be turned off by the math. I actually also don't know the math, Maybe Pri and Chima and Toby will know the math, but I don't. And all we'll be doing is just going through the code. I just encourage you to go step by step. If you're having a problem setting up your environment, let us know, then we can go through this together next time. I don't know what you guys think. We'll hear some, okay, Chima says yes. It's too simple for him. He wants some real, but you can see that we're going to go through, this is going to be an end-to-end, then we'll move to classification, we'll train model, SVM, decision trees, random forest, how to reduce dimensions, then we'll go to some unsupervised learning techniques, then deep learning, and then artificial neural networks and deep learning and custom models and loading and pre-processing data. And we're gonna do some processing sequences here, Almira with reinforcement learning. And then we'll do some NLP. And then we'll do some GANs for Toby here. And we're gonna go back to reinforcement learning. And then we're going to just keep going. And then at this point, as we go along, we'll start moving to the first AI course as we'll start to gain more knowledge together, okay?
Just one tip that I have for I'm sure like if you scroll down in the chapter, there's this appendix, and that there when you open it, so there's this not if you it should be like on every chapter's at the end of every chapter. Yeah, if you go to the, is that the appendix? So if you go back to chapter 1, in the end there's this appendix, and there is a link to the Jupyter notebook that has all the codes. If you run the code that is presented in the book, most of it will give you some error function that it is not defined, because there's so many functions that he has defined them in somewhere else, and he's just explaining. And I think maybe it's just a good thing to like go over the codes that he's presenting in his Jupyter notebook. You can just get it on GitHub, and also like the link that I sent to the chat box. I think it was written, like it was written in 2011, but I think it was written by the same guy, because it is exactly using the same lines of codes and like exactly using the same data. So I'm thinking that the authors are the same. So you can use that. I'm planning to do that basically, to go over the, I'm just gonna do exactly what he's doing and like try to like decode the code that he's writing, and that will help us learn more. At least what we learn.
Absolutely, absolutely. I don't know why I lost my chat. Oh, I found it. Yeah, I'll send this to people. This is what Elmira said in NJ Training Academy, right?
Yeah, exactly. I'm sure we will be talking about the Jupyter notebooks, like all these, like the Colab or like any
exactly
online platforms. Okay, so
yeah, so that will be our next. I want people to go try, but next week that's what we're going to do. We're gonna be coding, okay? So because what we need to do is that as we go, like I said, this is flipped classroom. We need to be able to pull up new Kaggle notebooks so that you're learning through the week, and ultimately all of us actually can work on a project, on a similar project, you know. But this, yeah. So thanks, Elmira. Chimaini, oh, I think you said yes. Abby, I hope you're not discouraged.
And no, I'm not discouraged. Like, so this link that Chima sent, no, Elmira sent, I can, because I don't know where else to go for the Jupyter codes and stuff like that. This is the only thing I can use.
Actually, no, let me just, Judy, if you bring up the first chapter, like the actual book's first chapter. If you scroll down. At the end
that the place I found is here.
Okay, so appendix A. So if you click that, it's not so right there it says you can just get the code in that notes section. It says that you can just get the code from GitHub, and then you are here, so you will see that all of these Jupyter notebooks assigned for each chapter has its own Jupyter notebook, and you can either we will talk about like what platform to use to like make use of those code examples.
Okay, thank you.
In fact, if you go to the Jupyter notebook, you can see that, like, you know, I can say, let's say the machine learning landscape, right? And all you need is a Google account, and you can see this is going to generate the data here now, right? So this is what was happening. And obviously you can see that the code has definitely changed, right? But you know, so this is a, so you can even just open the you know, you can open the document in Google, and you just need a browser to run it.
Okay.
Yeah, you can just for the next time you can just open up a Colab account. Just Google Colab, and then if you have that, you can just open it in that platform, and then you can just run the code in that.
Okay.
Okay. Toby, any thoughts?
None from my end. I checked the NJ Training Academy. I was wondering because Elmira said you can get the updated codes there. I don't know if that was what she said. So I went through the site. Okay,
I think it's the same code, right?
Okay.
But yeah. And as we go along, we'll come up with small tasks that you can do alongside, right? So this is where the first AI course will be very good as we learn more concepts. But this is going to, at the end of this book, I just want us to be able to, if I'm saying, oh, I use that, this model, you'll be like, oh, I know why they use that model, and you can like sit through a complex discussion and really make sense out of it. And even +1, if you can go through the code and understand it and fix it. Something else, and be able to inspect results and do something like that. Agree?
Yeah, I generally like this. Like, I'm also getting to know new things, and this would be helpful in long run. One more thing I wanted to highlight is the importance of sampling bias. They have mentioned in this chapter, so that is also a good concept. If you look into the first chapter, page number, I don't know, page number is 700 and no, page number is 26, I guess.
Okay. Do you want to remind people what sampling bias is?
Yeah, basically, it's the same thing as we discussed for the trained depth set. Like, if you don't collect the good quality data, like if you collect the data from the biased region, then obviously your model is not going to generalize well on the other unseen data set. So they presented an example of US elections or UK elections, I don't know, US elections, I guess, where they have collected data when they predict, yeah, this one, sampling bias.
Right. So this is finish explaining it.
Yeah, so basically they have while preparing the model, they have collected data from one particular region and they gave the result, but in reality the result was totally different because they forgot to sample the data set correctly, as well as to take it from more diverse platform. So I mean I wasn't aware of this thing, so I liked this thing.
So as we start to think, because all of us want to build our own things, we'll be generating the data. So one of the experiments that I'll do is go through some of the projects and see how the data was generated, and we can critique and say, how could you get into problems with this, right? Because that's how the superpower really, honestly, is understanding how from end to end, being able to work with teams. And number two is understanding like, what do I need to build the model, right? So if Abby says, I want to build a model for workflow, what data am I going to pull? How am I going to make sure it's representative? How am I going to make sure it can be used in Dallas and Emory and Africa? So that type of data, I think, is going to be a big discussion for us. And that's why I like the flip method, and we will all learn from each other, okay? So I'll see you guys next week. Usually I'm just gonna keep it at noon unless there's a desire to move it at another time, okay? And we're going to be going through chapter 2. I'm going to invite everyone to a Slack channel just for the book, just a book club. And if you have problems, don't wait till Saturday. Just ask there, run things. If you find a good resource, please share it, right? The big benefit of this, I know you can read the book on your own, is that we can do this together and all learn at the same time, okay?
Awesome.
Yes, Amira?
Yeah, I have a question. That like, so I'm in Chicago. It's there is this similar, like at noon Eastern time, there is this other like international neuroradiology conference.
Oh, okay.
I would rather to use this one. This is what I did today. But if you like, I was wondering if you maybe like 1 o'clock your time would be best for me. But if I'm the only person, you never mind.
So I think that's going to be dependent on Pri and Toby's time, because he's in New Delhi and Toby is in Nigeria. What's a good time for you both? Pri is probably the most extreme because it's almost 12 hours.
Yeah, for me it's 9:30 my time and 11:30 your time, I guess.
11:30 my time. But that would still be 11:30 to 12:30.
Yeah.
So is the international neuro thing going on for like the rest of the year or just like a few months?
It started like for COVID thing, and it looks like it's happening every Saturday from 11 to 12 Eastern time, and it's just something that but again that's my future, so I can just if I have to like choose between one thing, I'd rather to choose this one because this is more important to me at the moment. So
yeah, and we'll keep recording too, so we could start at 11:30, so you'd be on for 30 minutes.
No, I will.
And, right, and then if you have to jump off and catch up on the second half, would that be okay?
Yeah, I mean, I just wanted to like, this is also happening. If it works for you, we can just move it like 1 hour. But 11:30 is actually good. Also, I can just have the other one running in the background. So if I have to like it, so I think that will work for me. Thank you.
Let's try 11:30 next time, and let's see. Okay, same link, and then let's see how it goes. Okay.
11:30 your time, so it's gonna be 10:30.
10:30 for you.
So like half an hour earlier.
Yes.
Okay, so
and for Pri 9:30, and Toby that will be
4:30.
huh?
4:30.
4:30 p.m.
4:30 p.m.
Okay. And Tim, are you in the US though right now? Yeah.
Good term, yes.
So I think we okay. Let's see that. Okay. See you 11:30 with coding next time. So Abby, you're gonna be explaining all these codes to us. I just want to encourage you to use Google. I do that a lot. You know, if you're here and you're saying, man, what was this code that they wrote? So the thing about what people are suggesting is that you don't have to write everything. You can spend the time running the code and understanding it, right? And adding your own notes. So you could say, man, what was, like, what's def? You know, what's def? And, you know, and you can just search so all this code is in Python. And you know, you can just search what's def. You may not find the load housing data, and we'll go through it, but you know, you spend a little bit, and this will start to make sense with some time. But because all we're doing is that we're defining a function, so you can learn about Python function that's going to load the data and find this CSV part. And so when you say housing, you're saying housing, load housing data, and this is the thing that we are calling. So I could have said load Judy data, and I'll just have to call load Judy data here. So it's going to take some time, but you'll start to understand the language. But I just encourage you to, you know, go through everything. You'll be like, oh, what's described? You can just search online and see what's described, and it's going to tell you, oh, this is what described does. You're going to get better at understanding how, you know, you should at least read through this and be able to understand the technologies that we're going through, okay?
All right, I'll do that.
Okay. Okay, bye, Tim.
Bye. It's nice meeting y'all.
Thank you. Bye.
Bye.
Yeah.